students, welcome to math class. Today I discuss on chapter 8 topics quadrilaterals. At first, some basic concept. Here we need to know about median. So we consider a triangle which is ABC. At first we find the midpoint of side AB, BC and AC. Let the points are D, E and F. Now if I join the point A with D, then this line segment is called median. That is, when I join the vertex with the midpoint of opposite side, then it is called median. Similarly, we get another median joining C with F and B with E. Now in triangle ABC, we have three median which are AD, BE and CF. Now alternate angle and parallel. At first we consider a line segment AB, then another line segment CD. If I join B with C, then we get this situation. If AB is parallel to CD, then angle ABC equal to angle BCD. This angle is called alternate angle. Vice versa, when these angles are equal, then we may say AB and CD are parallel to each other. Now parallelogram. Here I draw a parallelogram ABCD where the side AB and CD are equal and parallel, and AD and BC are also equal and parallel. If I join B with D, then these two angles are equal and this angle is called alternate angle. Now in exercise 8.1, we first solve the theorem question number 5. In particular enunciation, it is given BO is the median of triangle ABC and we produced up to D so that BO equal to OD, and we get a quadrilateral which is like ABCD. It is required to prove this is parallelogram. Now in triangle AOD and triangle BOC, OA equal to OC as O is the midpoint of AC, OB equal to OD by construction, an included angle AOD equal to included angle BOC as they are vertically opposite angle. So now the triangle AOD and triangle BOC are congruent following SAS theorem. Now we may say AD equal to BC as these two triangles are congruent, and angle OAD equal to angle OCB. Now instead of OAD, we may write angle CAD and angle ACB. Their alternate angle. That is, we may say AD is parallel to BC. As AD is parallel to BC and AD and BC are equal, so we may say ABCD is a parallelogram. Proved. Now we'll solve question number 6. Here a diagonal of a parallelogram divides in it two congruent triangles we need to prove. So at first particularization, here we draw a parallelogram ABCD where BD is the diagonal. It is required to prove the triangle ABD is congruent to the triangle BCD. In triangle ABD and triangle BCD, we may write AB equal to CD. As we know, the opposite sides of parallelogram are equal. We may write AD equal to BC. It's also opposite sides are equal. BD equal to BD means it is common side. So the triangle ABD is congruent to the triangle BCD. Following triple S theorem. Proved. Now question number 7. Here we need to prove if the opposite sides of a quadrilateral are equal and parallel, it is a parallelogram. At first particularization, in the quadrilateral ABCD, AB equal to CD, AD equal to BC, and AB parallel to CD, AD parallel to BC, it is required to prove ABCD is a parallelogram. Construction. We join A with C and B with D. Here are some hints. In Theorem 2, we learn the opposite sides and angles of a parallelogram are equal. As here in this question it is given the opposite sides are equal. To prove parallelogram, at first we need to show the opposite angles are equal. So at first, depending on equal side, we start our proof. We consider two triangles ABC and ADC, where AB equal to CD as opposite sides are equal, AD equal to BC, opposite sides are equal, AC equal to AC, which are common side. Now the triangle ABC and triangle ADC are congruent, which is also triple S theorem. As these two triangles are equal, we may say the angle ABC is equal to angle ADC. Instead of ABC, we may say angle B, and instead of ADC, we may say angle D. So here we get the opposite angles are equal. Now in the given question, as another information given, the opposite sides are parallel. Depending on that concept, we start part 2, where we join another diagonal AC and BD. We found this that the diagonals intersect at the point O. Now we consider two opposite triangles AOB and COD, where AB equal to CD, opposite sides are equal. Since AB and CD are parallel and BD is their transversal, we may write angle OBA equal to angle ODC, which are alternate angle. Again, AB is parallel to CD and AC is their transversal, so we may say OAB equal to OCD, which is also alternate angle. Now we may say the triangle AOB congruent to the triangle COD. ASA theorem. That is, here we get in the first case the opposite angles are equal, and now we get in triangle AOB and triangle COD as they are congruent, so we may say OA equal to OC and OB equal to OD, that is, the diagonal bisect each other. Since opposite angles are equal and diagonal bisect each other, ABCD is a parallelogram. Proved. Following this, you may solve activity
Now
1
we'll prove
and
question
2.
number 8. Here we need to prove if two diagonals of a parallelogram are equal, it is a rectangle. Particularization in parallelogram ABCD, if AC equal to BD, these two diagonals are equal, then we need to prove ABCD is a rectangle. Here hints, in a rectangle we notice that the opposite sides are equal and all angles are right angle. As it is a parallelogram, so opposite sides are already equal, but now here we need to prove all angles equal to right angle, so that we just consider the two angles D and C. We would like to prove these two angles are right angle. Now we'll consider two triangles which contain these two angles like ACD and BCD. Now in these two triangles, AD equal to BC, CD equal to CD, which is common side, and AC equal to BD, which is given. Now we may say the triangle ADC is congruent to the triangle BCD, following by S theorem. That is angle D equal to angle C. We notice that in a parallelogram, the opposite angles are equal and sum of four angles equal to four right angles. Now we may add angle A, B, C and D, which is equal to 4 right angles. We just replace angle A with angle C as the opposite angles are equal and angle B with angle D. Now here you get 2 angle C plus D equal to 4 right angle. Dividing both sides by 2, we get angle C plus angle D equal to 2 right angle. Now from 1 we may replace angle D with angle C. That is, here we get 2 angle C equal to 2 right angle and angle C equal to 1 right angle. As we get angle C equal to 1 right angle, so angle D must be equal to 1 right angle. That is, angle B is also 1 right angle. That is, angle A is also 1 right angle. So ABCD is a rectangle. Proved. Now question number 9. Here we need to prove if two diagonals of a quadrilateral are mutually equal and bisect each other at right angles, it is a square. Particularization, here in the quadrilateral ABCD, the diagonal AC equal to BD and AC is perpendicular to BD and they bisect at the point O. Bisect means they divide equally. Here we need to prove ABCD is a square. Hints. In square we know all sides are equal and all angles are right angle. So at first we'll prove all sides are equal and after that we show all the angles equal to right angle. Now we consider the triangle AOD and triangle AOB, where OB equal to OD as AC bisect BD means divided into equally two parts. OA is their common side and included angle AOB equal to included angle AOD as they bisect each other at right angles. So angle AOD must be equal to angle AOB equal to 1 right angle. Now we may say the triangle AOB is congruent to the triangle AOD as two sides and their included angle are equal. That is followed by SAS theorem. Now we may say AB equal to CD. Similarly, we may prove that AB equal to BC and BC equal to CD. That is, we get all sides are equal there. Now in the second part, to prove all the angles equal to right angle, we consider the triangle AOB. Here we say OA equal to OB because as it is given AC equal to BD, we may take half of AC equal to half of BD, and half of AC means OA as it is bisect each other. So instead of half of BD, we may write OB, that is OA equal to OB. Now you may say angle OAB equal to angle OBA because their opposite angle of the side OA and OB. Now as angle AOB equal to one right angle which is perpendicular, we may say angle OAB and angle OBA equal to 45 degree because in triangle AOB as angle AOB equal to 90 degree, so sum of other two angle must be equal to 90 degree. But as angle OAB equal to angle OBA, so they be individually 45 degree. Now similarly we may prove that angle OAD equal to angle ODA equal to 45 degree. That is, if I add angle OAB with angle OAD, we get 45 degree plus 45 degree equal to 90 degree. That is, angle BAD equal to 90 degree. So we may say rectangle ABCD is a square.